Hi everyone. Before we get started with this video, I just want to say that I now have a channel membership, which you can join. And by joining the channel membership, you will get access to my curated topicals. For now, I only have further mechanics as well as further pure 2, if I'm not wrong. But more components will be added soon. Yeah, so you'll get unlimited access to them, as well as you will also be entitled to ask me any questions directly. So, like if you're having any problem with a question that you can't solve, you can just directly ask me, and we can solve it together on a call. And you can ask me any other queries if you would like to clarify them with me physically on the call. Okay, so that's what this membership gives you. That's the perk. Okay, so yeah, that's all. And yeah, so today we're going to be solving A-level maths, A-level further maths 9231, paper 32, further mechanics, October, November 2025. This paper is 1 hour, 30 minutes long. So we will try to finish within that time limit. So without further ado, let's get started. All right, so for the first question, we are told that a particle P of mass m is attached to two light inextensible strings, each of length L. So yeah, you can see in the diagram, there's two inextensible strings connected to P. The end of one of the string is attached to a fixed point A, so this one right here, and the end of the other string is attached to a fixed point B, the one right here, the one below, with A vertically above B. All right. Angle APB is a right angle. Yeah, so the angle right here, the particle P rotates in a horizontal circle at a constant angular speed omega with both strings taut. So taut means that the tension is not zero for both of the strings. Yeah, so that's all the info we have. And using this, we need to find the tension in string AP in terms of M, G, L, and omega. Okay, so first things first, let's draw a free body diagram of the particle P. Okay, so obviously the first force, since it has mass, there's weight acting on P, which acts vertically downwards. So that's just mg. And since there are two strings connected to P, those strings tension is also acting. So for AP, let's assume it's acting this way. So there's going to be, I don't know, T1. And then for BP, the other string is also acting towards the center. So we're going to let that be T2. Okay. Yeah. So yeah, these are the only forces that I can think of. And yeah, let's draw a datum line through the center of the circle to label these angles, just 45 degrees. So the reason I did that is to make it easier for us to split the tensions into vertical and horizontal components. We will need it to solve for these forces later. Okay, yeah. So first things first, we have to know that when a particle, it moves in a horizontal circle, since there's no acceleration in the vertical plane, so there's no acceleration up or down, the forces acting vertically, they're all in equilibrium. Okay, so that's the first condition that we're going to apply. So we're going to solve for the vertical forces first. Okay, so far we have the weight as the only purely vertical force, as well as the vertical component of both tensions. So that's T1. So for T1 is going to be T1 sine 45 upwards, and for T2 is going to be T2 sine 45 downwards. Okay, so therefore T1 sine 45 is going to be equals to mg plus T2 sine 45. So yeah, we can simplify this. Okay, so sine 45 is square root 2 over 2, square root 2 over 2, T1 mg plus square root 2 over 2, T2. Okay, let's multiply by 2 on both sides. So square root 2 T1 equals to 2 mg plus square root 2 T2. Okay, so for tidiness sake, we'll move the T2 over to the other side. Then you'll get square root 2 T1 minus T2 equals to 2 mg. That's your final equation. So this is going to be our first equation using the fact that the vertical forces are in equilibrium. Okay, now we're going to do the same for the horizontal forces. However, you have to know that in a horizontal circle, the horizontal forces are not in equilibrium because that's where the acceleration is acting. So yeah, in a circle, there's this thing called centripetal acceleration, which is given by centripetal force, and that centripetal force acts in the same plane as a circle towards the center of the circle. So in our case, the centripetal force consists of the horizontal component of T1 as well as the horizontal component of T2. Okay, so we're going to use F, where F is the centripetal force. F equals to m. R is the radius of the circle. Um, omega squared. Yeah. So F, as I mentioned, is just the horizontal component of the two tensions combined. So it's just T1 cosine 45 plus T2 cosine 45. And M is just M. And as for R is basically the length from the center of the circle to the edge of the circle. Okay, so using basic trigo, we can say that, yeah, so the hypotenuse is L. This is adjacent, so it's just L cosine 45. Okay, so it's ML cosine 45 omega squared. Yeah. So yeah, from the left-hand side, we can actually factor out cosine 45 degrees, bracket T1 plus T2, goes to ML cosine 45 omega squared. So yeah, first things first, we can see that we can cancel out the cosine 45, and therefore we're left with T1 plus T2 equals to ML omega squared. Yeah, so yeah, I don't think we can simplify anymore. So yeah, this is going to be our second equation that we're going to use to solve. Okay, so again, let's go back to the original question. We need to find the tension in string AP. And this tension in string AP, we define it as T1. So we need to find T1. So to start, let's use equation 2 and make T2 the subject. So doing that will give us ML omega squared minus T1. So this equation 3. Okay, unfortunately, not much space, so I'm just going to jumble up all the working. We're going to combine. So we're going to sub 3 into 1. So you get square root 2 T1 minus T2. So that's ML omega squared plus T1 equals to 2 mg. Okay, so I'm just going to add and expand everything all at once. So this is 2 square root 2 T1 minus 2 ml omega squared equals to 2 mg. And then, yeah, we have 2 square root 2 T1 equals to 2 mg plus 2 ml omega squared. Okay, and then simplifying this, you would get T1 is equals to mg plus ml omega squared over square root 2. But if you want to rationalize the denominator, it's just going to be square root 2 over 2 m g plus L omega squared. Yeah, so yeah, this would be a final answer for this entire question. Let's move on to, okay, let's see. Yep, let's move on to the next question. Okay, so before we get started with the next question, I made a silly mistake in the first question, all right? So when I was expanding this, yeah, I put 2 in front of ml omega squared instead of square root 2. So I'm going to rectify that. Okay, square root 2. Yeah, so here's we're going to be square root 2 as well. Okay, so this is 2 square root 2 square root 2. Okay, let me just erase this. Yeah, so doing that will give us mg over square root 2 plus ml omega squared over 2. So that would give us half m bracket the square root 2. Okay, half m. So this one is half, yeah, square root 2. Yeah, square root 2 mg plus no mg, just square root 2g plus L omega square. Yeah. Yeah, so yeah, this would be a final answer. Yeah, let's move on to the next question. Okay, so for this question, we're told that one end of a light elastic string of natural length A, so natural length A, modulus of elasticity 2 mg, is attached to a fixed point A on a rough horizontal surface. Okay, so this is the keyword rough, so that means there's friction involved in here. Okay, and the other end of the string is attached to a particle P of mass m. Okay, so let's draw it out. So this is the rough horizontal surface. This is the string, and this is the particle P. So this is A, and this is P. The particle and string rest on the surface. The coefficient of friction between P and the surface is mu. So yeah, mu is the coefficient of friction. The particle P is initially held in equilibrium. So it was in equilibrium at a distance 4/3a from A. Okay, so that means the length of this string has to be 4/3a, where it's at equilibrium. So that means all the forces acting on it are balanced. And then after that, the particle is released from rest. Okay. Yeah, so that's what we're told. And for the first part, we are told that given that the string never becomes slack, so that means the tension never becomes 0. So that means there's always EPE because it's an elastic string. We need to find the minimum value of mu. Okay, so I believe for this we are going to need to okay, so all right. Let's try. Oh my goodness, what is this? All right, yeah, so okay, let's try forces. Yeah. Okay, so never become slack. Actually, no, let's not do forces. Yeah. Um, yeah, let's do the energy method in here. Okay, so um yeah, so initially, let's find the total energy initially before it's released from rest. So since it's on the horizontal surface, there's no change in GPE, so we can ignore that. And it's not moving, so no KE. So the only force acting on it is it's what do you call EPE. Yeah, so there's only EPE. And to find the EPE, just go to your MF19, yeah, and go to elastic strings and springs. Just use this formula, lambda x squared over 2L, where lambda is the modulus of elasticity, x is the extension, and L is the natural length. So I'm going to apply that. So lambda is 2 mg, and x squared is, so we're already given the length of the um, string. So 4 over 3a minus the natural length a squared over 2a. So yeah, 2 is cancels out, equals to mg um, a over 3 squared over a. So then you get mga squared over 9a. So this is a's cancel out. Therefore, final answer is just going to be mga over 9. Yeah, so this is the initial EPE. Okay, so now we're going to find the final energy. Okay, so released from rest. Yeah, let's just continue with the string. Okay, so I guess EPE, we can just let it be equals to 0. All right, and EP, yeah, EP will let it be 0. GP is obviously 0. KE, that's not 0. But okay, give me a while. Okay, so yeah, we can consider KE to also be equals to 0. Like if you think about it, if there's KE, um, that's going to, yeah, that's basically going to, how do I say? Um, yeah, so if there's KE, it is going to reduce, like if there's no KE, it's going to reduce the work done by the friction, okay? And the reason why EPE is 0 is because we are assuming that since they said it never becomes slack, so that means the string cannot be less than its natural length. So once it's at its natural length, it stops moving. It doesn't do anything. So therefore no KE and no EPE. Okay. So yeah, therefore there's only work done by the friction. Work done by friction. Yeah, which is just okay. So friction itself is just mu. Oh my gosh. It's just mu times r, and the distance moved is just the extension, which is a over 3, and r itself, okay, just draw a quick diagram. So this r, this is the mass mg. So there's no acceleration vertically, so r is just equals to mg. So this is just mu mga over 3. So this is the work done by the friction. And using conservation of energy, we can equate them. All right. So mga over 3 equals to mu mga over 3. Yeah, so you can see the mga over 3 cancels out. No, sorry. Mga over 9. Oh my goodness. Yeah. Uh, A, A, okay, yeah. So yeah, here only mg cancels out. Therefore, mu is just 1 over 9 times 3, which is equals to 1 over 3. So yeah, this would be final answer for the first part. Let's move on to the next part. Okay, now for the second part, we are told that mu is equals to 2, and using this, we need to find the extension of the string when the particle comes to rest. So that means KE is obviously equals to 0. Okay, so again, here we have to use our conservation of energy. All right, so again, let's write down the total initial energy. Okay, so initially we already established that there's only elastic potential energy, which is just mga over 9. And yeah, that's the only energy. And then finally, um, there's obviously EPE, but we don't know what it is. So EPE, we're just gonna use that formula, lambda x squared over 2L. So lambda is 2mg, and then x is, yeah, just x. So that's what we're going to be finding over 2L with L, the natural length, that is A. Um, yeah, so the 2's they cancel. Then you'll get mgx squared over A. So this is the first EPE term. Okay, and yeah, and there's no KE. And obviously, there's a work done against friction because from the initial point to the final point, it moved along the rough surface. So obviously, it had to do work against the friction that it was experiencing. So we're also going to include the work done. Okay. So yeah, work done is just the force times the distance. So the force, we already know what it is, mu mg, mu r. Okay. And as for the distance, okay, so let's draw a quick diagram in here. So the initial length is 4 over 3a. And okay, let's say this is the point where it comes to rest, okay? So the length here is just going to be a, the natural length, plus x. So the distance moved altogether, just going to be 4 over 3a minus x. So that is 1 over 3a minus x. Yeah, it's 1 over 3a minus x. So that's the distance that it moved, okay? So it's just going to be a over 3 minus x. Oh yeah, we're already given what mu is. Okay, so it's just half mg a over 3 minus x. And then we expand it out. It's going to be mga over 6 minus half mgx. So this is the work done. Okay, I think to make it simpler, we're also going to just combine it into a single fraction. It's going to be mga minus 3 mgx. Yeah, so this is the work done. Now we are going to combine these. Okay, we're going to add these up and equate it to each other. All right, so the final total energy, mgx squared over a plus mga minus 3 mgx over 6 is equals to mga over 9. Okay, so the left-hand side, let's combine it into a single fraction, 6a. So multiply by 6 is 6 mgx squared plus mga squared minus 3 mgax equals to mga over 9. All right, now let's cross multiply. Okay, so doing that, you'll get 9 times 6 mgx squared plus mga squared minus 3 mgax equals to 6 mga squared. So expanding, you'll get 54 mgx squared plus 9 mga squared minus 27 mgax equals to 6 mga squared. Okay, so I think we can cancel out the mg. Okay, so this is 54 x squared plus 9a squared. Let's move the 6a squared to this side. Minus 27ax equals to 0. Okay, so you'll get 54x squared minus 27ax plus 3a squared equals to 0. So we divide by 3, all these. 54 divided by 3, you'll get 18x squared minus 9a squared plus a squared equals to 0. Okay, so yeah, now we can solve for x, okay? So to solve for x, we can just use the quadratic formula. So b is minus 9a, so minus b, that's just 9a plus minus square root of b squared. That's minus 9a squared, so 81a squared. Minus 4a is 18. C is a squared over 2, a 2 times 18. Okay, so simplifying, you get 9a plus minus 4 times 18, a squared. So 81a squared minus 4 times 18. You get 9a squared, so square root of 9a squared is just 3a all over 36. Okay, so therefore you will get x is 9 plus 3a divided by 36. You'll get 1/3 a. And x, you'll also get 9a minus 3a divided by 36, 1 over 6a. So, what extension should we choose? Hmm. Oh, wait, we can just um okay, so find the extension of the string when the particle comes to rest. Okay. Oh, we can just wait. Yeah, so this is how we determine which one to reject. So obviously the distance that we move 1 over 3a minus x, it has to be more than 0. And obviously if you substitute x equals to 1 over 3a, you will get 0. So that doesn't make sense. So we would have to reject that. And therefore our final answer is 1 over 6a. So yeah, this would be our final answer for this second part, as well as the entire question. Let's move on to the next question. Bismillah. Okay, so for this question, we are told that a uniform lamina OABCD in the form of a rectangle OBCD. Damn, that sounds funny. So yeah, this rectangle right here joined along the edge OB, so this edge, to a quarter circle OAB. Length of DO is KA, so you can see it's given here. Length of OB, the radius is A. Lamina sits in a vertical plane with its edge CB on a horizontal surface. See the diagram. Yeah, so CB is resting on the horizontal surface. And using that, we need to find in terms of K, A, and pi, an expression for the distance of the center of mass above the horizontal surface. Okay, so let's say the center of mass is here, and we need to find the vertical distance above the horizontal surface. So in general, we basically have to find y bar. Okay, all right. So first things first, we need to find the areas of the rectangle and the quarter circle, as well as of the lamina as a whole. Okay, so OBCD, we are going, that's just KA square. OAB, that's just pi A square over 4. All right. And the lamina is just KA square plus pi A square over 4. Okay, let's factor out the A square. So it's just A square K plus I over 4. Yeah, so this is the lamina. Okay, now we are going to find the distance of the center of masses of the rectangle and the quarter circle individually. Okay, so let's find the y bar of the rectangle of OBCD. So to find the y bar of the rectangle, you just have to find the dead center of the rectangle and find the vertical height of it from the horizontal surface. So that's very simple. It's just a over 2. Now let's do the same for the quarter circle OAB. So this is a bit challenging. So in brackets, they actually told us you may use without proof the result for the center of mass of a circular sector. Yeah, in the MF19. So that's what we're going to do. So it's of a circular sector. So it can be used for semicircle, quarter circle, like any piece of a circle, basically. Okay, so yeah, just go to this section and look for this. Yeah, so this is the formula that they told us to use. So circular sector of radius 2r and angle 2 alpha. So our angle, since it's a quarter circle, it's pi over 2. Yeah, pi over 2 because the right angle. So alpha is pi over 4. And r is just a. Yeah, so r is a. So yeah, we're told that the circle, so it is 2r sine alpha over 3 alpha from the center. Okay, so yeah, so this one right here from the center. Actually, no, let me draw the arrow here. It is 2r sine alpha, 2r sine alpha over 3 alpha from the center. Yeah. Okay, so r is 2a sine alpha. Alpha is I over 4, and this 3i over 4. Yeah, so yeah. Okay, so sine pi over 4. So 45. Yeah, that's just square root 2 over 2. So let's just square root 2a over 3 over 4 pi. Okay. So this it just becomes square root 2a times 4 over 3 pi. Yeah, so this is the length of it. Yeah. Okay, so now the question is, how do we find the vertical distance? Okay, so okay, I think I have an idea. So okay, so let's all right. So first of all, we're going to say distance of COM of OAB from center. That's just 2a sine pi over 4 times 3 pi over 4. That's a square root 2a divided by 3 over 4 pi. So that is just 4 square root 2a divided by 3 pi. Yeah, so this is the distance. You have one thing you have to know about the center of mass is that since it's in the dead center of the quarter circle, the angle that it makes with this, it has to be 45 degrees. And since this is 90 degrees, this angle right here is also going to be 45 degrees. So therefore, to find this height here, it's just going to be um yeah, it's just gonna be sine 45. Okay, so therefore a y bar OAB is gonna be 4 square root a over 3 pi times sine I over 4. um Wait, no, a minus this. So it's just a minus sine I over 4 is 45. Yeah, so that's just gonna be 8a over 12, I know, over 6 pi. Yeah, so this is 3, this is 4. Okay, so Oh my goodness. Give me a while again. Okay, so yeah, so this is the vertical distance of the center of mass of OAB. Uh yeah, it's literally just A minus 4A over 3 pi. Yeah, so this is it. And now, yeah, we're going to find the y bar. Okay, so to do that, you just use a principle of moments. You multiply the y bar, which is your perpendicular distance, by the mass. So since it's a uniform lamina, the mass is directly proportional to the area. So you can just essentially multiply by the total area. Okay, so the area of the lamina is a square. So y bar times a square times k plus pi over 4. That is equals to y bar OBCD. Okay, so A over 2. So OBCD is KA square plus for OAB it's A minus 4A over 3 pi times pi A square over 4. Okay, so okay, what do we do? Okay, so let's factor out A. Okay, first, so y bar A square times k plus pi over 4 goes to A cubed over 2 times k plus A cubed over 4. Actually, just A cubed. Okay, so A cubed, yeah, 1 minus 4 over 3 pi times pi over 4. Yeah, so yeah, so a square cancels, this just becomes a. Um, yeah, so okay, let's just combine it into a single fraction. So y bar 4 pi plus 4k equals to ka over 2 plus a times, okay, so this is 3 pi. So this is just going to be 3 pi minus 4 times pi over 4. Oh, okay, good. There's more space. So y bar pi plus 4k over 4 equals to ka over 2 plus a times pi times 3 pi minus 4 over 12 pi. So yeah, the pi's, they cancel each other. Then we get y bar pi plus 4k over 4 equals to ka over 2 plus a times 3 pi minus 4 over 12. Okay, so y bar pi plus 4k over 4 equals to, okay, so 12, 6, 6 ka 3 pi a minus 4a. Yeah, and now we can just find y bar, which is just 6 ka plus 3 pi a minus 4a over 12 times 4 over pi 4k. So this 1, this 3. So y bar is 6 ka plus 3 pi a minus 4a over 3 times pi plus 4k. Yeah, so let's see if it fulfills of our conditions. Ka pi. Yeah, it does. So I think we can stop here and conclude this as our final answer. Let's move on to the last part. Okay, so for this last part, we are told that the lamina is on the point of toppling about B. So what this means is that, yeah, so that means the line of action of the weight acting through the center of mass, it passes exactly through B, okay? And to find that out, we have to use the distance x bar, which is the distance from the center of mass to the edge CD. Okay, so first step, we need we have to find the value of k. We have to find what x bar is. Okay, so the process of finding x bar is very similar to finding y bar. Okay, so x bar, just like finding y bar, you multiply by the area of the lamina, which is a square times k plus pi over 4. So this time I'm gonna just combine it into a single fraction straight away. So uh, just 4k plus pi over 4. And then this would be equals to the the horizontal length of the center of mass of the rectangle times the area of the rectangle first. Okay, so area of the rectangle is ka square, and the length of the center of mass of the rectangle is ka over 2. Okay, so so doing that gives us ka over 2 times ka squared. Yeah, yep. And then you add it with that of the quarter circle. All right, so to find the horizontal distance of the center of mass of the sector from here to here, we first have to find this length. So in the previous part, we found this length here. So and that is just 4 over 3 pi. So this is also 4a over 3 pi. So since it's a 45 degree cos 45, cos 45. So this is also 4a over 3 over pi. And then you just add k plus a to find the entire distance. Okay. So this is 4a plus 3 over pi. Okay. Yeah. 4a over 3 over pi plus ka plus ka. And then oh shoot. Okay. Uh, so sorry for the disruption. And then you multiply it by the area of the quarter circle, which we found here as well. It's just pi a squared over 4. All right. So it's just pi a squared over 4. All right, so this you get x bar a square I plus 4k over 4 equals to a cubed k square over 2 times 3 pi 4a plus 3 pi a k times pi a squared over 4. So the pi's, they cancel out. Okay, so let's factor out all the a's out of this. So you get x bar a squared I plus 4k over 4 equals to a cubed k squared over 2 plus, yeah, let's just factor out a cubed. So this is 4 plus 3 k over 3 times 1 over 4. Yeah. So, okay, so let's cancel out the a square. All right, so we have x cubed I plus 4k over 4. A times k squared over 2. A times 12 uh, 4 plus 3 pi k over 12. Yeah, let's just combine it into a single fraction now. So x bar I plus 4k over 4 is equals to 12. Okay, so 6k squared plus 3 pi k plus 4 times a. Yeah, so let's continue it in here. In the exam, please use the additional page. Okay. Yeah, so this one is just going to be x bar x bar is equals to um 6k squared plus 3 pi k plus 4 over 12a times 4 over pi plus 4k. So this is 1, this is 3. So this gives us 6k squared plus 3 pi k plus 4 over 3 times pi plus 4k a. Yeah, so this is x bar. Yeah, and now we are going to now we're going to equate x bar with Ka because, like we said, the line of action of the weight, which starts from the center of mass, passes exactly through B. So x bar has to be equals to Ka. Okay, so x bar Ka. Yeah, so I'm just gonna do all the working like really fast. Okay, so you'll get 6k squared plus 3 pi k plus 4. The a's will obviously cancel out, equals to 3k pi plus 4k squared. So this cancels out. Let me see. Okay. Um, okay. Give me a while. Okay, so yeah, this is not supposed to be 4, supposed to be 12. Okay. So yeah, 12k square. Yeah, we can leave the 4 on this side. Then you'll get 12k square minus 6k square gets 6k square equals to 4, which would give you k square is 2 over 3. And therefore, k is going to be square root of 2 over 3. K equals to square root 2 over 3 is our final answer for this part, as was the entire question. Let's move on to the next question. Okay, so for this question, we're told that a particle Q is initially positioned at a distance d vertically above a particle P. So Q is directly above P, and they are both distance d above each other. Okay, so we're told a particle P is projected with speed u at an angle alpha above the horizontal. Okay, at the same time, Q is projected at an angle beta below the horizontal. Okay, so both particles move freely under gravity, so pure projectile motion, and the particles collide at a time t. So they collide after the projections. So this last part, we can infer that, they travel the same horizontal distance as well as the total vertical heights. They have to add up to d, and they did it in the same time as well. Okay, so both of the projectiles they intersected at that exact point at that exact time t. Yeah, so for the first part, we need to show that this result is true. Okay, so first things first, I think it'll be useful to draw a diagram. Okay, so we're told that P is, no, sorry, Q is above P. Okay, so this is going to be Q, and this is going to be P. And we are told that P is projected with speed U at an angle alpha above the horizontal. At the same time, Q is projected below the horizontal. So this is the horizontal. And let's say that this is Q's. So Q is, yeah, they did not say what's the speed of Q. So I guess we're gonna have to go with V at an angle beta below the horizontal. Yeah. So yeah, these are that. And yeah, after like this, they probably like meet around here. Okay, we can estimate. Yeah. So from the diagram, we can see that they both travel the same horizontal distance in the same time, and that their total vertical distance they travel, it must add up to d. Okay. All right. So okay, since they want us to find d, we think it's better if we start with finding the vertical the heights, like the vertical distances that they moved. Okay. So starting with P. All right. So to find the vertical height moved in the time t, just go to your MF19, go to the Suvat formula section, which is right here on mechanics. So we want to find the vertical distance. So obviously has to have S, and we know the time and the initial velocity. So therefore, this is the perfect formula for us to use. So we're going to use this. Okay, S equals to ut plus half AT squared. Okay, so yeah, we're just going to call it SP. It's going to be U. So U, since we are finding the vertical like distance move, U is going to be the vertical component of the initial velocity of P. So therefore, it's going to be U sine alpha times big T. And plus half, and then A is minus G, okay? A is minus G. Minus G big T squared. Yeah. So simplifying this, you're gonna get U big T sine alpha minus half G T squared. So this is for P, okay? As for Q, we're also going to use the same formula. However, do note that for Q, since it is projected downwards, its trajectory won't be like this. Instead, it's going to be more like this. So it'll just go straight downwards only. So therefore, the acceleration that Q will experience is positive G. All right. So SQ is going to be, okay, the initial speed of Q is V sine alpha. Yeah, V sine beta. Sorry. V sine beta. T, yeah, UT plus half AT squared. So half GT squared. So SQ is VT sine beta plus half GE squared. So this is the second equation. Yeah, we can't add these equations up yet because you can see that this is just in terms of big U and big T. It's not in terms of the V, okay? Oh yeah, by the way, change this to big U. Yeah, all right. So now we need to find an expression for V in terms of U. And to do that, we're going to have to use so this is the vertical. So we're going to have to find the horizontal distance, okay? We're going to have to use the horizontal distance. Okay, so like I said before, from this diagram, we can see that they move the same horizontal distance in the same time. Okay, so we can obviously equate the horizontal distances traveled by each of them in time t. All right. So to find the horizontal distance, you just take the horizontal component of the velocity, which is always constant. So for p, that is big U cosine alpha times t, and for q, that is small v cosine beta times t. So yeah, these all cancel out. Then you can see that v is literally just big U cosine alpha over cosine beta. So this is the third equation. Now we are going to substitute the third equation into the second equation. So therefore, SQ would be U big U cosine alpha over cosine beta times sine beta times t plus half gt squared. So sine beta over cos beta, that's just tangent beta. So SQ would be U, big U, cosine alpha, tangent beta. Okay, UT, cosine alpha, tangent beta, plus half gt squared. So yeah, this is the final expression for SQ. Now we're ready to find what D is. So as we said earlier, D is literally just SP plus SQ, which is equations 1 plus equation 4. Okay, so D is just UT sine alpha minus half GT squared plus UT cosine alpha tangent beta plus half gt squared. So yeah, the half gt squared terms cancel out. Therefore, you will just get d is equals to, yeah, you can factor out the ut from the final expression. You'll get ut bracket, yeah, let's start with the cos or sine. Okay, you'll get sine alpha plus cosine alpha tangent beta. So yeah, this would be a final answer. Okay, we can write shown for the first part. Let's move on to the second part. Okay, so now in the second part, we are told that the particles collide when P is at maximum height. Okay, so yeah, now we are told that given that alpha is 30 degrees and 60 degrees, we need to find D in terms of U and E. All right, let's first substitute alpha and beta into the previous expression we found. Okay, so D is UT, a bracket, sine alpha, so sine 30 degrees plus cosine 30 degrees times tangent 60 degrees, and you get D equals to UT sine 30. So sine 30 is half, cos 30 is square root 3 over 2, tangent 60 is just square root 3. Okay, so simplifying all that, you get UT 3 over 2 plus half, that's 4 over 2, so that's just uh, over 2 plus half. So 4 over 2, you get D equals to T. So now we are going to have to find an expression for T in terms of G. Okay. All right. So for that, we have to use this information given to us, that P was at its maximum height. So when a projectile, like a normal projectile like this, is at its maximum point, it means that the vertical component of its velocity is 0. Okay. So yeah, we can use that. All right. Yeah. So to find the final velocity, knowing the initial velocity and the time taken, let's go to MF19. Yeah, we can just use this formula. V equals to U plus AT. Okay, so V in this case is just 0. U is, well, the vertical component of the initial velocity. So that is, for P is UT sine alpha. I'll just U U sine alpha. So U sine 30 degrees times T. Yeah. And and obviously, yeah, minus, I mean, A is minus G because it's going up, but the weight is acting downwards, so therefore acceleration is negative. Yeah, minus G, big, oh my goodness. Yeah, minus G, big T. All right. So, sine 30 is half. So 0 equals to half UT minus GT. So yeah, you will just get half UT equals to GT. Why did I put the T? Yeah, I just realized, yeah, you don't have to put this T. You just need to put the initial velocity. Oh my goodness. Okay. So just half u, half u. Yeah. Now we can make t the subject. So doing that, you would get u over 2g. Okay. So yeah, this is gonna be our first equation. Actually, no. This is our first equation, and this is our second equation. So we're gonna substitute the second into the first. And you get d equals to 2u times u over 2g. So 2's cancel out. Therefore, final answer, you just get u squared over g, right? So yeah, this would be our final answer for part B. Let's move on to the next question. Ready for more? Okay, so for this question, we're told that two uniform smooth spheres A and B of equal radii are on a horizontal surface. Their masses of m and km respectively. So sphere A is m and the mass of sphere B is km. All right, and we're also told that sphere A is moving with speed u. So that's initially at an angle alpha with the lines of center when it collides with sphere B, which is stationary. So initially, A is moving at speed u at an angle alpha to the lines of centers, and sphere B was completely stationary. That's initially. Immediately after the collision, sphere A moves with speed v at an angle 2 alpha with the lines of centers. So this speed you see here, v, is the speed after the collision. All right. Yeah. So it is given, yeah, so we're also told that tangent alpha is 3 over 4. Okay, so for the first part, we're told to find v in terms of u. Okay, so this is a really simple question. So to do that, you have to know that, like for oblique collisions like this, the vertical component of the velocities before and after the collision remains the same. So, for example, A, okay? Initially, A had, oh my gosh. So initially, A had a vertical component of u sine alpha. However, after the collision, it changed to v sine 2 alpha. Okay? So these have to be the same. So therefore, u sine alpha must be equals to v sine 2 alpha. And now we're ready to solve. So u sine alpha. So to express this sine 2 alpha in terms of sine alpha, you can just use the double angle formula in your MF19. Yeah, right here I underlined it. Sine 2a equals to 2 sine a cosine a. All right, so this is 2 sine alpha cosine alpha. Yeah, so we can move the cosine alpha to the other side, then you get u sine alpha over cos alpha, which is u tangent alpha. Then you will get 2 sine alpha. And then you can make v here. So v is going to be equals to u tangent alpha over 2 sine alpha. Okay, so u tangent alpha. So tangent alpha is 3 over 4 u and 1 over 2 sine alpha. So times 1/2 and 1 over sine alpha. Well, it's just 1 divided by, let me just draw a quick triangle. So opposite, adjacent. So 3 over 5. 3 over 5. Yeah, 3 over 5. 3 over 5. Which is 3 over 4u times half times 1 over 3 over 5. So you get 5 over 8u. Yeah, so therefore the final answer is just v is equals to 5. V is equals to 5. V is equals to 5 over 8u. So yeah, this would be a final answer for the first part. Let's move on to the next part. Okay, so for the second part, we are told to find the coefficient. Oh my gosh. We are told to find the coefficient of restitution between the spheres in terms of k. Okay, so to find the coefficient of restitution, we have to know the final and initial speeds of both spheres. However, we don't know that, unfortunately. We don't know the final speed of sphere B. So first thing, we have to obviously find that first, all right? Okay, so to find that, we have to use the conservation of momentum first. All right, so let's find the total initial momentum. So initially, so for oblique collisions like these, we take the momentum with respect to the horizontal component of the velocity. So the component that is along the line of centers. Okay. Yeah. So initially, the total momentum, since B is stationary, obviously the momentum of B is zero because mass times velocity. That's the formula for momentum, right? So yeah, that's zero. So initial momentum is just the initial momentum of A. All right. So the initial momentum of A is just m times u cosine alpha. So mu cosine alpha plus km 0. Yeah. And that is equals to m. Yeah, so we know the final velocity of A, which is mv cosine 2 alpha. Cosine 2 alpha. Okay. Plus km. I'm gonna let the speed of the final speed of B of B be VB. Okay? Yeah, so yeah, we can cancel out the m's. So yeah, there we have u cosine alpha. So V, we can use the previous thing, 5u cosine 2 alpha. So again, for this cosine 2 alpha, we can use a double angle formula. Yeah, let's use this, 2 cos square A minus 1. So this is going to be 2 cosine square alpha minus 1 plus KVB. Yeah, so so we can just use the value of cosine alpha using this mini triangle we made, which from here is just 4 over 5. Okay, so 4 over 5u equals to 5 over 8u to cosine alpha squared. So cosine alpha is just 4 over 5 squared minus 1 plus KVB. Yeah, so let's just do it. Okay, so 2 times 4 over 5 squared minus 1 times 5 over 8 is 7 over 40 u plus KVB. So KVB, just make it a subject. It's just 4 over 5u minus 7 over 40. which gives us a nice number of 5 over 8u. Yeah, so this is what KVB is. Okay. All right, just isolate it to make it VB. So VB is just 5u over 8k. So this equation number one. Okay, good. We have more space. All right, now we have to find the coefficient of restitution. So the coefficient of restitution is the relative speed of separation, so big S over big A. So big A is the relative speed of approach, okay? So the relative speed of separation we can take by taking the difference between any two particles, like the difference between the final velocities. Okay. All right. All right. So we can take the difference of, let's say, the final velocity of B, which is VB, minus the final velocity of A. Again, the horizontal velocities. All right. And depending or not if they're in the same direction, one of them has to be negative. Okay. So if you just like visualize like quickly, right, what direction B would go, common sense would tell you that B is going to go in this direction. So VB is going to be here. So since the final velocities of both A and B, like at least horizontally, is in the same direction, yeah, we can say that both VA and VB, they're positive. So therefore, it's just going to be VB 5U over 8K minus VA. So VA is just going to be just going to be V just yeah, it's just going to be V cosine 2 alpha, which you already found right here. It's just 7. Oh my God. It's just 7 over 40u. Yeah. And then over the relative speed of approach. So here's the thing. For the relative speed of approach, you have to reverse the direction um, of the particles which you took the differences of. So for the speed of separation, we took the final velocity of B first minus the final velocity of A. But now for the speed of separation, we have to take the speed of approach. We have to take the initial speed of A minus the initial speed of B. Okay, so the initial speed of A is u cosine alpha. So u cosine alpha is just u 4 over 5 minus b. So yeah, b is just 0. Okay, yeah. So yeah, we can we can just factor out u. We get 5 over 8k minus 7 over 40 divided by 4 over 5u. So the u's, they cancel out. And then we get E is equals to 5 over 4, 5 over 8k minus 7 over 40. Yeah. Yeah, which would just give us 25 over 32k minus it's 8, so it's just 35. So 856 over no, it's 7 over 32. Yeah. Yeah, so it's 25. over 32k minus 7 over 32. Yeah, so yeah, this would be our final answer for this second part. Let's move on to the last part. This is okay, so for the last part, we're just told to find the range of the possible values of k. Okay, so to do that, you have to know that the coefficient of restitution, it has to be between 0 and 1, and it can be equals to 1, but it cannot be equals to 0. So this is the range of the coefficient of restitution. And using our previous expression for the coefficient of restitution, we can solve for E, okay? So yeah, 25 over 32k minus 7 over 32 less than or equals to 1. So we can add 7 over 32 to both sides. 7 over 32, 25 over 32k less than or equals to 1 plus 7 over 32, which is 39 over 32. So yeah, let's multiply on both sides by 32 over 25 to get rid of this fraction here. So 32, okay, so 7 over 32 times 32 over 25. You would get 7 over 25, 1 over k, 7 over 32, 39 over 32. There you get 39 over 25. And now since, we have a reciprocal, to just get k, we just flip everything and you flip the inequality signs. So you'll get k is between 25 over 39 and 25 over 27. So therefore the final answer is going to be k is between 25 over 39 and k is less than 25 over 27. So yeah, this would be the final answer for this last part, as well as the entire question. Let's move on to the next question. Okay, so for this question, we are told that a fixed smooth sphere with radius A and center O rests on horizontal ground. A particle is projected horizontally from the highest point A of the sphere with speed u. So this particle is right here, is launched horizontally from the very top of this big sphere in front of us. The particle begins to move in a vertical circle along the surface of the sphere. And then we're also told that the particle loses contact. So this is the keyword here. Loses contact means the normal contact force at that point becomes 0 when the sphere is at point B, where the angle AOB is theta. So at point B, the angle is theta, and this is where n becomes 0 for the particle. And after leaving the surface of the sphere, particle moves freely under gravity before striking the horizontal ground with speed 3u at an angle beta to the horizontal. So this is the part that they're talking about. Yeah, so moves freely under gravity means this is purely projectile motion. Okay, yeah. So using this, we need to find the value of beta. Okay, so first things first, to find the value of beta, we obviously have to know the speed at this point where it loses contact with the sphere. So basically the speed at point B. Okay, so yeah, let's do that. Okay, so to find the speed at point B, yeah, I'm gonna let the speed at point B be close to V. So let's use the forces method first, and then we'll use the energy conservation. So for vertical circles, you have to use both energy conservation as well as centripetal force formula by analyzing the forces. Okay. So at point B, we're told that it loses contact, so there is no normal contact force. So the only force acting at that point is its weight, which is just mg. Okay, now it didn't tell us the mass, but yeah, we can just let the mass be m. Yeah, so the mass is mg, and mhm. and the centripetal force, it has to act towards the center of the circle that is producing. So here, so this the way it acts, and by simple trigo, you will know that you can easily find out that the value of that component is just mg cosine theta. Okay, so that's the only centripetal force acting on it. Okay, so yeah, we're just gonna use F, where F is the centripetal force, mass times v squared over uh, r. Yeah, so again, F is just mg sine theta equals to mv squared over a. Yeah, so yeah, r is just equals to a, and then m gets cancelled out, and therefore we have v squared equals to ga cosine theta. So yeah, this is the first equation, and now we're going to use conservation of energy to solve the rest of the problem. Okay, so yeah, so initially at A, so first of all, for any vertical circles question, you should always set a datum line passing through the center where the GPE is equals to 0. So you should always set the GPE here to 0. So yeah, we take the GPE at B, which is just mg a cosine theta plus half mv squared, so half mv squared, the ke, and we equate it to the ke down here, so half m 3u squared minus, so the reason why it's minus is because it's right below the datum line, and it's exactly a meters below. Okay, so this is going to be minus mga. Okay, yeah, so yeah, we should just find what ga cos theta is. All right, yeah. Or we can substitute this. Okay, let's just simplify this first. Half mga cosine theta, 9 over 2 mu squared minus mga. Okay. It's going to be 3 over 2 mga cosine theta equals to 9 over 2 mu squared minus g. Yeah. So let's cancel out the m and multiply both sides by 2 over 3. Then you'll just get ga cosine theta. Yeah, so 2 over 3 Oh my gosh, 2 over 3, 9 over 2 u squared minus GA. So GA cosine theta, you'll get 3 u squared minus 2 over 3 GA. Yeah, so therefore V squared. Yeah, unfortunately we didn't get it. Yeah, so now we have a new expression for V squared, which is just 3u squared minus 2 over 3 GA. So yeah, I guess it's the second equation. Yeah, now to find uh yeah, now we're gonna equate the energy at here with the energy in here. Okay. So at A, the energy, the GPE is just mGA, and the velocity is half mu squared, and that is equals to half m 3u squared minus mGA. Okay, so that will give us 2 mGA equals to 9 over 2 mu squared minus half mu squared. Yeah, then you would get 4 mu squared equals to 2 mGA. Yeah, so the m's they cancel, 2 also cancel. So 2u squared, you'll get equals to GA. This equation 3. And now you can sub 3 into 2. You'll get V squared equals to 3u squared minus 2 over 3 times 2u squared. So you'll get 3u squared minus 4 over 3u squared, which is 5 over 3u squared. Yeah, so I think we got the expression for V squared in terms of U. So this would be the intermediate answer, which we can use to find the value of beta. Okay. All right. So, okay. All right. So, what should we do now? Okay. Most really under gravity, striking the horizontal ground, an angle beta. Okay. So, oh, wait, we can use yeah, so since it's projectile motion and we know the height, right? And we know the initial and final velocity. Um, wait, yeah, we can easily find beta. Yeah, so as I was saying, yeah, so since we know okay, let's go to mechanics. So since we know the initial and final velocity as well as the distance that it dropped, the vertical distance, we can use this formula right here. V squared equals to u squared plus 2as to solve. Okay, so this is the projectile part. So this is where we solve our second part. Yeah, so V squared is obviously just the vertical component of this. So it's just 3u sine beta. Okay. Or is it also possible to just okay, you know what? Never mind. Okay. Okay, so first of all, we need to find the angle that it gets projected downwards. Okay, all right, so let's do a close-up of this. So this is the surface that it goes away from. So the surface, yeah, so this is a normal, and this is the angle theta. So we want to find this angle. So the normal is actually perpendicular to this, so this is actually tangent. So therefore, this is going to be 90 minus theta. Yeah, uh, yeah, it's going to be 90 minus theta. Yeah, so therefore, I think it's better if we just consider the horizontal speed. Actually, yeah, let's just consider the horizontal speed because the horizontal speed remains constant, right? Yeah, so the horizontal speed, so this V is just going to be V cosine 90 degrees minus theta. Okay, so it's just going to be V cos 90 degrees minus theta equals to um 3U cosine beta. 3U cosine beta. And using complementary angle laws, we can tell that V sine theta, V sine theta is 3U cosine beta. Yeah, so to make things easier for us, we're going to square both sides. So V square sine square theta equals to 9U squared cos square beta. Okay, so we know what V squared is. It's just 5 over 3U squared sine square theta 9U squared cosine beta squared. So the U cancels, uh, and the cosine square beta just becomes 5 over 27 sine square theta. Yeah, so to find cosine beta, we need to also know what sine theta is. Okay, so I guess we can use the first equation that we got here. Okay. Um, yeah, so the first, so, okay. So yeah, from equation one, yeah, so V square is GA cosine theta. And then we can sub V square equals to 5 over 3U squared and and equation 3 into 1. So then you'll get 5 over 3U squared, GA, which is 2U squared cosine theta. Okay, so so cosine theta, you will get 5 over 6. But we want sine square theta, so that's very easy to find. So we know that sine square theta is just 1 minus cos square theta from the trig identity. So we can just do 1 minus 5 over 6 square. That would give us 11 over 36. Okay, so therefore, cosine square beta is going to be 5 over 27. That's 11/36, which is 555/972. And then yeah, cosine beta is just going to be the square root of this 55/972. And therefore beta is just going to be cosine inverse of this. Just press your calculator. 55/972. Okay, before that, let's check what's the unit of beta. Okay, they didn't really specify, but in the context of further mechanics, it's better if you set it to degrees. Yeah, so the final answer we get in degrees is 76.2 degrees to one decimal place. So yeah, this would be our final answer for this entire question. Let's move on to the next question. Okay, so before we move on to the last question, I realized I made a minor mistake in here. Yeah, so the projectile is actually supposed to be V sine 90 minus theta. Yeah, so V sine 90 minus theta. So yeah, you can see here this is 90 minus theta, and I want the horizontal component, so that is indeed V sine yeah, not cos, is V sine 90 degrees minus theta. Yeah, so because of that, all the signs, at least on this side, oh my God, it's all gonna be cos. It's all gonna be cos. Yeah, so it's gonna be V cosine 90 cos cos cos. Yeah, we didn't have to find this. It would have been good. This was unnecessary. Yeah. Yeah, so this, shoot. Yeah, so therefore, yeah, this is just gonna be, yeah, it's just gonna be 5, yeah, over 6 squared, which is gonna make this, it's just gonna make this, 1, 2, 5. Yeah, so 5 times 5 times 5, 27 times 36, yeah. So therefore cosine beta is just gonna be square root 125/972. So beta is cosine inverse 125/972, which gives us 125/972, 69 degrees to one decimal place. So yeah, this is our final answer for this entire question. Let's move on to the final question. Okay, so for this question, we are told that a particle P of mass m kg is moving along a rough horizontal table. So again, there's a resistive force, friction. Okay, so it moves along a rough horizontal table. It has displacement x meters from a fixed point O on the table and velocity v meters per second at time t seconds. And we're also told that the particle P is subject to a resistive force of magnitude mg kV newtons, where k is a positive constant, and a frictional force of magnitude mu mg. So we have two resistive forces, the mg kV newton one and the mu mg frictional force. And then the initial conditions is that the particle P is initially at O with speed u meters. So what this means mathematically is that at time t0, the displacement of x is 0 because it's at O, and the speed of v is u meters. Yeah, so these are the initial conditions. Yeah, so using all this, we need to show that t is equals to all this. Okay, so to do this type of question, since we're not given any expression for acceleration or like velocity directly, we're gonna have to use Newton's second law, F equals to ma. Yeah, so F is just the resultant force. Yeah, that like all the forces that are acting on particle P. So the only forces acting on particle P are resistive forces. So therefore, to find F, we're just gonna do minus mg kV minus mu g. And this is gonna be equals to m a. Okay, so we'll leave the a alone for now. Now we're going to simplify. So a is just going to be minus gkv minus mu g. Okay, I think we can also factor out minus g. So a is minus g bracket kv plus mu. Yeah, so I can see that in this final expression that we have to find out there is only v and t, there's no x. So therefore, since we have an expression for acceleration in terms of v, we're going to use acceleration dv dt to solve this. So replace a with dv dt. So dv dt is equals to minus g kv plus mu. Yeah. So we're gonna move all the v terms because you can't move dv to the other side over to the dv side, the left-hand side. And we're gonna move dt over to the other side and keep the constant or t terms on that side. Okay, so doing that, we'll get 1 over kv plus mu dv equals to minus g dt. Yeah, so now we're gonna integrate this. Okay, so to integrate the left-hand side, you can see that it's in the form f prime x over fx. Okay, so fx is kv mu, and when you differentiate it with respect to v, you'll just get k. Okay, so we're gonna replace the numerator with k over kv plus mu. However, this just changes the entire value of this thing. So to make the value the same, we're also going to divide by k by putting a 1 over k on the outside of the integral. Okay. And then for this, it's just minus g t plus c. Yeah, and then for this, since inside the integral, it's exactly in this form. It's just going to be 1 over k ln kv plus mu. And this is minus gt plus c. Okay, now I guess it's time for us to substitute the initial conditions. So here we have t, so I'm going to substitute t equals to 0 and v equals to u. Okay, yeah, so doing that, you'll get 1 over k ln k big U plus mu equals to g times 0. So you just get c, and then c, it becomes 1 over k ln k big U plus mu. Yeah. So yeah, now we can substitute back into the original equation. So you got 1 over k ln modulus of kv equal to 1 over k u plus mu. So okay, now we have to make T the subject. So do that, just isolate GT. So doing that, you'll get 1 over, over K on KU plus mu minus 1 over K ln KV plus mu. Then GT is just going to be 1 over K ln KU plus mu over KV plus mu. Okay, let's see if that's close to a form. Okay, that's good. Yeah, so to just get T, just divide both sides by G, then you'll get T is equals to 1 over GK ln K big U plus mu over KV plus mu. So yeah, we can write shown as this the exact expression that we have to show. So yeah, this would be our final answer for the first part. Let's move on to the next part. Okay, so now we are told that U is 10, K is this, and mu is 0.2, and we need to find the distance P moves before coming to rest. Okay, so in order to do this, I think it's best if we have an expression for X in terms of V, okay? So let's take the original expression that we had from here, which is A equals to minus G KV plus mu. So K is 0.04 K. No, 0.0 V plus mu, so plus 0.2. And this time we're going to use the other expression for acceleration in terms of V and X, which is V dV dx. So a little derivative on how, a little lesson on how like you can derive this expression from scratch. So we know that acceleration is dV dt. Yeah, so using chain rule, you can actually replace this with dV dx times dx dt. So we know dx dt that's equals to v, so therefore we get a equals to v times dv dx. Yeah, so yeah, we're gonna do that. So v dv dx minus g 0.04 v plus 0.02. Okay, so as we can see, the dv is actually like just on that side. You can't move it over to the other side, so you're gonna have to divide this, okay, by the v expression on both sides, okay? So you'll get v over 0.04 v plus 0.2 dv, and then dx, just multiply, you get minus g dx. Okay, so now you integrate this. Okay, so to make this easier, I'm gonna actually change it a bit by just multiplying both the numerator and the denominator by 100. Okay, so it's just gonna be 100 v 4v plus 20 v dv. This is gonna be minus gx plus c. No, there's no v here. Okay. Yeah, unfortunately, there's still all multiples of 4. So simplifying, you'll get 25v over v plus 5 dv. Yeah. So now, to integrate this, we're gonna do this technique. Okay, this technique called the long division. All right. So let's just do some rough long division of this. So 25v plus 0, we divide it by v plus 5. So yeah, 25v. So 25 plus 125. So yeah, you divide by 25. This is minus 125. So the quotient, that's the whole number here. Oh my God. Plus, the remainder minus minus 1. Oh my gosh. Minus 125 over the divider, which is v plus 5 dv. It's equals to minus gx plus c. Okay, so integrating this, you'll get 25v minus 125. Yeah, minus 125 ln um, v plus 5. Yeah. And then you'll get this equals to minus gx plus c. Yeah. So now we're gonna add the initial terms, the initial conditions. So when x equals to 0, v equals to u, that's what we're gonna add. So substituting x, substituting x equals to substituting x equals to wait substituting substituting x equals to 0 and v equals to u, we get c equals to 25 u minus 125 ln big U um, plus 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 5. Yeah. So this is equals to yeah, this equals to 200 250 minus 1 2 5 ln 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 15 15. Yeah. Yeah, so yeah, using this we can uh solve for x, okay? So it was initially at its speed. Yeah, okay. So yeah, we can solve for v now. Okay. So therefore we have 25. Why is it always 25v minus? Okay, I was gonna. Okay, so yeah, as I was saying, yeah, we can finally solve. There's a bit of a trouble going on. I don't know, this glitch. Equals to minus gx plus 250 minus 125 ln 15. Okay, so we can sub v equals to 0. So doing that, we get minus 125 ln 5 equals to minus gx plus 250 minus 125 ln 15. Yeah, so simplifying all that, x is just going to be, just press your calculator. So 125 ln 15 minus 125 ln 5 minus 250 divided by negative 10. You will get 11.3 meters to 3 SF. So yeah, this would be our final answer for this second part. Let's move on to the last part. Okay, so for part C, we're told to find the average speed of P over the period it is moving. So basically the average speed of P from t equals to 0 all the way to when it stopped. Okay. So to find the average speed, we need to know the total distance, which we found in the previous part, over the total time. That's the part that we don't know. Okay, so we're going to use this expression to find it. All right, so yeah, let's find t. So t is 1 over g, and k is 0.04. So, oh my God, 0.04. Yeah, 0.04 times ln modulus of k small u plus mu. So k is 0.04 small u. Right, so small u is 10 plus mu, so plus 0.2 plus 0.2 plus 0.2 over kv plus mu. So k 0.04, v is obviously 0 plus mu, so plus 0.02. So let's find the exact ln value first. So 1 over 10 plus 0.04. That is 5 over 2 ln 0.04 times 10 plus 0.2 plus 0.04 times 0 plus 0.2. That is 3. So this is 5 over 2 ln 3. Okay, so this is t. And as for the distance x, the exact ln value is 125 ln 15 minus 125 ln 5 minus 250 divided by negative 10. Okay, yeah. So therefore the average speed is just going to be this ln 3, 125 ln 3 minus 250 divided by negative 10 divided by 5 over 2 ln 3. And this would be equals to 125 ln 15 minus 125 ln 5 minus 250 divided by negative 10 divided by 5 over 2 ln 3, which would give you 4, yeah, 4.10 meters per second to 3 SF. So yeah, this would be our final answer for this last part, as well as the entire question. And we have come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe for more future videos regarding A-level maths and further math, past paper solving videos, as well as topical videos. If you have any questions, queries, or feedback, or any future video ideas, or any papers that you want me to cover, please feel free to leave them down in the comments below. And yeah, I will see you again next time. And don't forget to join my membership, which I just launched. Okay. Yeah. I guess I'll see you all again next time. Okay. Thank you.